On your even page, so that's the one on the right side, we're going to write our title, and our title is going to be 1-5 for Chapter 1, Lesson 5. I hear some talking. And we're going to talk specifically about zero and negative exponent rules. And then today's date is the 9th. Okay, so let's start with the zero rule. So zero rule for exponents. And we're going to kind of work through an example of this to get to our answer. Okay. So this is kind of go back to the quotient rule. Let's say we've got a to the 5th power, and I want to divide it by a to the 5th power. Okay, so when we first were exploring the quotient rule, they said, well, what does a to the 5th mean? So we rewrote it as a times a times a times a times a. All right, and what does a to the 5th mean? Well, it's a times a times a times a times a. And then we talked about, okay, well, what we're going to look for is there anything top and bottom that's the same? If there is, we're going to simplify. So do I have anything that I can simplify in this one? Anything? Danielle? Yeah. If I have a divided by a, what do I have left? What's a divided by a? No. Something divided by itself doesn't give something. What's a divided by a? What's 3 divided by 3? What's 1,000 divided by 1,000? Yeah, it doesn't matter what your term is as long as the number in the numerator and the number in the denominator are the same, it equals 1. It happens there. It happens here. It happens here. It happens here. It happens here. Or as Daniela said, it happened everywhere. So what do I have left when I finish with all of that canceling?
5.
How'd you get 5? But it doesn't tell you to add. What's the operation that's showing here? Yeah, all I have is 1 times 1 times 1 times 1 times 1 is 1. All right? So let's take this same problem and let's apply the rule. What did the quotient rule tell us to do to the exponents when the bases were the same? Okay, this is where you guys are supposed to be chiming in. What did it tell you to do with the exponents when the bases were the same? Do we add them? I thought that was the product rule. Can the product rule and the quotient rule have the same math? No, that wouldn't make sense. So what are we going to do with those exponents? Say it again, Kyle. We're going to subtract. Okay? What was amazing is how few of you just sat there and just started guessing operations. You have a source of information right in front of you. You could have just flipped back to the quotient rule. So the quotient rule says subtract. Well, what's 5 take away 5? 0. So here's what's strange. When I did the problem as an expanded multiplication problem on the top, and I canceled out common factors, I got a chain of 1s to multiply, and I got an answer of 1. When I applied the quotient rule, I got an exponent of 0. So I can put those two together, and I've just proved out the 0 rule for exponents. Anything, any value to the 0 power equals 1. That's a terrible looking one. as my daughter would say, always, end of statement, period. I wonder where she learned that one from. She hears it a lot from me. Any value to the 0 power equals 1. Always. End of statement. Period. No argument. That's it. Why? The value a to the 0 represents a number being divided by itself. You learned very early on that a number divided by itself equaled 1. Probably 3rd, maybe 4th grade. You learned that very early on, and that was one of the most exciting facts because you could always tell the answer because you knew it. This is the same thing. A to the 5th divided by a to the 5th. They're identical. When I divide identical things, I have to get 1. This is the easiest rule out there. If my exponent is 0, the value is 1. Done. Taj, you okay? Okay. Okay. These all represent exactly the same problem. So if this original problem equals 1, and this original problem equals a to the 0, what that's saying is those two answers have to represent the same value. So a to the 0 has to equal 1. Because I've proved in the top that a to the 5th divided by a to the 5th, which is a times a times a times a times a, over a times a times a times a times a, I think I got enough, that equals 1. And the quotient rule says, well, you can just subtract the exponents and you get 0 as your exponent. But they have to mean the same thing. So let's do one example on the odd page. And we'll come back and do a lot more. Directions are going to say simplify. And so the question is, does this hold true if the base is a number? Okay. Well, let's try it and see if it works. So 2 to the 4th means 2 times 2 times 2 times 2. And 2 to the 4th in the denominator means 2 times 2 times 2 times 2. Do I have anything I can cancel out top and bottom? I got a bunch of 2's, right? There's a pair of 2's. They equal 1. That pair equals 1. 2 divided by 2. 2 divided by 2. 2 divided by 2. So again, we get the answer 2 to the 4th divided by 2 to the 4th equals 1. That makes sense. I divided something by itself. I get 1. It's the identity property of multiplication, because I could rename this as 2 to the 4th times 1 over 2 to the 4th, multiplying reciprocals. But if I want to use my property, I'm going to subtract those exponents. And I get 2 to the 0 power. These two answers mean exactly the same thing. So I end up getting, 2 to the 0, which is what I got when I subtracted, gave me 1, which is what I got when I expanded. They mean the same thing.
So like on a test, if that was one of the problems, would you have to put 2 to the 0 power equals 1 as the answer, or would you only have to put 1?
I guess it would depend upon the directions. If the direction said simplify using exponents, then evaluate, okay, then I would want to see the exponent one and then the 1. Overall, if you're a smart person and you see the connection and you go, hey, I'm dividing something by itself, that's 1, bam. But if I say, what is the zero rule for exponents, and you have to write it out. You have to be able to tell me that anything to the 0 power equals 1. Okay? So yeah, if you're smart, I would write original problem equals 1. Bam, done. Okay? All right, let's go back because we've got another rule to do, and this is now the negative exponent rule. Rule. So up until this point, with the exception of a couple questions on the worksheet last night, the review worksheet, is that you guys had you've always had more variable in the numerator than you did in the denominator. So that when you did the quotient rule, you always had a positive number. Okay, what's going to happen with the negative rule is that you're going to end up with there being more of an item in the denominator. Okay, so we're going to explore this 2 different ways. So let's use a number. Let's do 8 to the 3rd power divided by 8 to the 5th power. Okay, so what I want to do is to first explore this through multiplication. So what does 8 cubed mean? Well, it just means 8 times 8 times 8. And then what does 8 to the 5th power mean? Well, it's just 8 times 8 times 8 times 8 times 8. And we're going to do the same thing that we've done every time in a quotient is, do we have like terms top and bottom? Can we cancel them out? So if we notice here, we've got 8 divided by 8, and we know that equals 1. That gives me 8 divided by 8, we know that equals 1. We have another 8 divided by 8, and that equals 1. So what am I left with in the numerator? What's in the numerator? There's no 2 in the numerator. Nope, there's no 8 times 8 in the numerator. Giselle? What's left in the numerator? 1, right? In the numerator, we're left with this. 1 times 1 times 1. The denominator has 8 times 8. This is the biggest problem that I see is when you guys cancel out and are left with 1s, you think that whole section has disappeared. You can't take it away. Numerator stays numerator, denominator stays denominator, okay? So what's 1 times 1 times 1? 1. And how many 8s was I left with in the denominator? 2. Now, I could go further. I could evaluate, and 8 squared would be equal to 64. So you would have 1 over 64 would be the final answer. Not 60, 64. Somebody needs to work on his... oh, that's even worse. Oh, that's even worse. Oi, oi, oi. So now let's go back and let's do the quotient rule. Same problem. So on this quotient rule, it says you're going to take your exponents, numerator, take away, denominator. You cannot change the order. It's always top, take away, bottom. Always. And what is 3 take away 5? Negative 2. 3 take away 2. And it's hard. You could say negative squared doesn't sound right, so we just negative 2nd power. And here's what we have to take. These are the same exact problems. These 2 answers are the same. So what happened when my exponent was negative? How did it change when I got rid of the negative exponent? What happened to my 8 so that it wasn't 8 to the negative 2nd power? It now became 8 to the positive 2nd power. Did it stay in the same position? Did it stay on the top and I just genie blinked the negative away? Or did that 8 squared need to move in order for that answer to have a positive exponent? Okay. Is the 8 here in 8 to the negative 2nd power in the same exact position as the 8 here in this problem? Okay. What position is this 8 in? What position is it in? Remember, what can all rational numbers be written as? What can all rational numbers be written as? As what?
Fraction.
Fractions, okay? So what part of the fraction is this? Numerator, okay? Fractions have a numerator and a denominator. This 8 is in the numerator. Where did this 8 end up? In the denominator. So a negative exponent was on a numerator number. It became a positive exponent when it went into the denominator. That's all a negative exponent deals with, is location of your base. Okay? So we're going to write down this rule. If an exponent is negative, shift the base, or shift its base, into the opposite location. Now I'm going to specify what I mean by this, because I'm going to show you a couple ways that this doesn't always show up the same way. It may show up tonight for you guys the same way, it may not. What I'm saying is this. If you have a numerator number with a negative exponent, so 8 is in the numerator, to get the exponent positive, we shift the base into the denominator. So he shifts into the denominator. The opposite is true. If I have 1 over 8 to the negative second power, so he begins where? In the denominator. Guess where he needs to go to become positive? He has to shift up to the numerator.
So denominator shift down.
No, it's opposite direction. So numerator went down. So if it's negative in the numerator, it goes down to the denominator. If it's negative in the denominator, it's going to shift into the numerator. Okay? So it's just basically you need to switch which side of the fraction bar the base goes in order to make the exponent positive. Now I'm going to think most of yours are going to have your exponent is negative in a numerator value. Okay, but I have seen them in the denominator, so I don't think you have any of this. Okay? So using just basic algebraic language, everybody good? Can I shift? Everybody good? Yeah. So let's rewrite the negative exponent rule in algebra. You don't have to, I would actually. It says this. If I have x to the negative nth power, it becomes 1 over x to the positive nth power. So all I shifted was from a numerator to a denominator. The vice versa. So if I have 1 over x to the negative nth power, it's going to become x to the nth power. So if we started in the denominator with a negative exponent, we're going to shift our base into the numerator to make it a positive exponent. Okay? Now this exponent doesn't have any numerical value. It's simply like on the number line. If you go to the right on the number line, your numbers are positive. If you go to the left on the number line, your numbers are negative. So let's do a couple quick examples on your other side. It's okay. If the directions say write using a negative exponent, so we're going to do this backwards. If your question is 1 over 5 squared, how are you going to rewrite that problem and put a negative in the exponent? I'm sorry, Jacob, did I say pack up and leave? No. So what's the answer to this problem? Careful. To the negative second power. The sign has to change if I shift the location. Okay, this was kind of a weird direction that wanted you to write it with a negative exponent. If we go with a positive exponent, it's going to go the other direction. Okay? All right, homework is that page 47 to 49. Good luck on it.